in isolated places in Texas. So it might seem logical to start with sedimentary, but I said I'm starting with igneous. What's logical about that? I'm working Elizabeth to death up here.
Is it because they all rocks came from the igneous rock?
They're known as the original rocks of the earth. Igneous were the first rocks. As the earth cooled from a mass of burning gases, it formed lava and magma that cooled further to form the two original. Do you remember those two?
Yeah. The salt
and
granite.
Granite, good. Wow, y'all don't need a review. Okay, and so I don't want anybody to say anything, and I don't want you to commit for the other groups around you, but just make a decision, and your first decision is which of the three is igneous, and tell me what your observable characteristic, most obvious characteristic to tell you that it's igneous is. And I'm going to call on a group, and you can choose the member of your group then to give me an answer. It's going to be group 1, 2, 3, 4, 5, okay? All right, here we go. Decide. And I want, once you have your decision, I want one hand holding it up for everybody to see. Everybody commit at the same time. Hold up your sample. Hold up your rock sample. Hold up your rock sample. Teresa, get your rock sample. Okay. So, group number 4. Tell me, what characteristic did you use?
Because it's granite.
Because it's what? No, I'm not asking you the name of the rock. I want rock's height. What is the observable characteristic, the number 1 characteristic of all igneous rocks?
Crystals.
Crystals.
That was ours.
Good. All right. Next, in your group, find for me the sedimentary sample.
Real small.
Everybody ready? So group 2, tell me your observable characteristic. Group 2.
That it's the layer, the striations.
The striations, the layers. Be careful about the word striation. Striation is a word that's used for which rock type? The metamorphics. And striations are different than what you're seeing in that sample. Those are layers. They're horizontal bedding deposits, okay? And so that is the sedimentary sample. And if I had my projector, but we're okay, tell me, find in your group, don't talk to anybody else, just your group, and don't commit until I call for them. Everybody's up at the same time. You only have one left. I should have done that from the beginning. So, igneous, but tell me the number 1 visible characteristic to help you know that. How do you know? Metamorphic, I'm sorry. Not yet. Give everybody time.
So it looks kind of like
This one there's some differences. Like if you look at this one, they're not all the same, like distance apart from each other. They go this way, and they like thicker here, and then it kind of from here they stay. Yeah.
All right, you ready?
Yes, ma'am.
I want group number 1 to tell me the observable characteristic.
Oh, the banding?
The banding, or she could have said the striations. Does everybody agree?
Yes.
And that was pretty easy for you? Yeah?
Yes.
Okay. All right, and so I gave you a copy from, have they got their Jim's books already? Did they get a Jim's book?
We have a Jim's book, but it's whenever, I think you were gonna use the handouts and then later give them the full.
Okay, you're going to get a copy of the Jim's book. It's
Yeah.
called Stories in Stone,
We have that.
and it's a wonderful book. Many of the labs that you've done already came from that book, modified for all grade levels, junior high, elementary, okay? So this is a rock cycle from the Jim's book. And so I want you on the front page just as quickly as you can. In my introduction, we're going to work today on the processes that link one rock type to the other to make the whole cycle. We've done it briefly, but you're going to do more today. But on your piece of paper, I just want you to jot down as many things as this group can think of that you know about igneous rocks, okay? So you in your group, on that paper that I gave you, not in your notebook, in the margin, out by igneous, write down a collective description of all the things you learned about igneous rocks. Brainstorm, get them down, hurry, I'm going to give you 2 minutes.
Yeah, 2 minutes. Mixture of minerals.
Just igneous rocks in general. Any igneous rock. What have you learned about it?
The original rocks of Earth. It can be extrusive or intrusive. It's the characteristics of it. Which may one's hold underground, the other hold above magma form. Pulls faster means you get the largest crystals. Larger crystals. Pulls slower, you get smaller. It would depend. Extrusive. Oh, yes, because you know, you're right, and then they have like no crystals. That's where yes, extrusive is cools faster. So no, I'm thinking
The closer it gets to the surface.
smaller, right?
The closer it gets to the surface, the faster.
So that would explain why extrusive has no, because obsidian has no crystals.
But that is magma.
No, wait, okay, you're right, that's the difference. The extrusive should have larger crystals, but the exceptions are the pumice and the obsidian because they got shot out. Okay, so.
The obsidian is really high.
Extrusive means it's been extruded. It's been projected. It's come to the surface.
Yeah. Intrusive is
Inside the earth. Not the core. Underneath
it's magma form, and then you can put, can be weathered to become sedimentary, can have heat pressure put on it to become metal.
I think it was
Yes. To become metal.
Because there could be, no. Okay, time's up. Are you ready?
Yes.
You're going to add to your tray if you hear something. You're going to add to your list if you hear something that's not already on there. Okay, Brennan, give me one characteristic of igneous rocks. Brennan, you're Brennan. Brennan, I'm sorry.
I said there's crystals.
There's crystals.
Yeah.
All right, everybody has that? Okay, next. Teresa, give me one.
Fast cooling igneous rocks have small crystals.
Okay. And you give me another one. Shayna? Did I say it right?
Yes, you did.
Shayna.
They can be intrusive or extrusive.
They can be intrusive or extrusive. Good. And that accounts for a difference in how they cool, right? Rates of cooling. So that's all building on that same idea. And Christina, give us another one. Is Christina not here? No? I'm going to remove her. All right, and Beatrice, give me one.
Mixtures, or it's a mixture?
We're trying to separate igneous, metamorphic, and sedimentary, and all rocks are mixtures, okay?
Okay.
So try again.
Formed from lava or magma?
Formed from lava or magma. That intrusive stuff is magma formed with big crystals. That extrusive is on the Earth's surface, grows little crystals. And Tim, another one.
One of the original rocks?
One of the original rocks of the Earth, correct? And Anna? Is Anna here? No. And Elizabeth?
Can I put the two types that we said, granite and basalt?
As the original rocks of the Earth, yes. You might just want to add that up behind original rocks. I think somebody's already said that. Is that Maura?
Yes.
I don't know, run through a list. I don't know what else to do.
Okay, I'm going to ask some questions then, Maura. All igneous rocks are made of which mineral family? I'm going to give you a hint. The tetrahedron is the basic building block of all of this family. Tim just said it.
The silicates.
The silicates. Silicon and oxygen.
The silicates.
The tetrahedron is the basic building block of all igneous rocks.
No, the
All right, does anybody in here, hands up if you have something on the list that hasn't been mentioned so far? Teresa, what?
The way to the fast cooling equals small, but the slow cooling equals larger crystals.
Yeah, that's what I was thinking.
We had that.
Okay. We kind of have it in different forms, but that's good to add. You have something different?
Very dense.
They are the most dense of all the igneous, of all the rocks. Yes.
But
Close on some metamorphics, but they're below. They would. Am I saying it?
It's
Yeah, that's right.
typically.
Yeah, typically, we can't say totally, because those at the surface are certainly not as dense
They're very
as.
frothy.
Is pumice an igneous rock?
Yes, it's extrusive though. So the extrusive ones are not going to hold to that, only the intrusive. Okay, so I'm going to ask a question. No more on your list? Okay, what lab did you do? This is Rochelle. What lab did you do to help you learn about igneous rocks?
I wasn't here.
She gets a pass. I didn't do one.
I'm going to leave you in this pile.
Okay.
Brenda?
What lab? During the summer training?
During summer training.
I know. That was rocks. That was
Crushed
minerals
the
will be scratched and acid tested.
We filmed it, right?
You did.
Okay.
Oh,
It was the I know. It was the I know.
Yeah, I know. Okay, Donna, what?
It was that when we grew the crystals.
And you grew the crystal.
When we bought them in the dish.
Do you remember these?
Yes.
Grown in 3 environments.
Ask me about the lab, about the minerals. I remember.
I'll ask you that in just a minute, okay? We're on the igneous right now. I should have done that first. Okay, do you think that igneous, well, first of all, tell me where in Texas are igneous rocks found?
Did you check Llano region?
In the Llano region. You went to Central Mineral Region, up around Llano, to gather them. And, wait, I have to call on somebody. Ooh, this says Greg. Let's go. All right, Greg, go. Igneous rocks, aquifers or aquatards?
I know that one.
Aquatards.
Aquatards, good. And for those who weren't here for summer, aquifer, aquatard, studying the water, what does aquatard mean?
It's
Elizabeth?
Is this where it's not, like permeable, or the water cannot?
The water can't go into it. And why is that just logical for igneous rocks? Because they are more dense, because the crystals grow interlocking with one another. There's no pore spaces to hold water, typically, and so they don't make good aquifers. Okay, let me check my list and see if you've missed anything. I think we're good. Okay, so go to the sedimentary, make your little list on the side. In your group, brainstorm, come up with all of the things you remember about sedimentary rocks.
Yes. Layers. It does still require compacting pressure.
Is Rochelle here?
But it needs that pressure. Yeah. So it can be parts of them can be organic, yep, creative.
Weathered rocks / organic material.
Yep. And that would be like limestone and coke. Is that one we saw that was all bits of shells? Right. How do you spell it? Oh, conglomerates. Yeah, look at you. Yes. I think these are the ones that have the. I'm not sure. COC. Yeah. That's the first part. Kind of like dating. I'm really impressed. That's crazy.
Okay, time's up. Time is up. Discussion stops. I'm going to call on you, but I'm going to remind you of one thing, and I want you to go back and write it for igneous. In your students' texts, they will identify igneous rocks as being the what? Made by fire. The word means fire made, okay? The word igneous, it's an Indian word. It means fire made. Okay, with that question, I have Johnny. And so sedimentary rocks in your students' text would mean made by what?
Sediments.
Made by sediments. Actually made primarily in water. They don't have to be, but the majority of them are made by water. Okay, and so next is Tanya. Give us a characteristic that your group came up with.
How do you do it?
Well, they're formed by erosion, deposition, and weathering.
Good.
That was good.
They all can be weathered. They can all then be deposited, and they can all be eroded, not just sedimentary, but the material that sedimentary rocks are made from is weathered material, right? Good. All right, give us another characteristic of sedimentary for our Lisa.
She's not here.
She's not here, okay? And Ashley.
You said they're aquifers?
She says they're aquifers. They make good aquifers. That's true. Next is Donna.
They're formed from heat and pressure.
Compacting and cementation.
Compaction and cementation. I'm throwing words out now.
Compaction and cementation, that's good. What did she first say that is not correct? Heat. So she was describing which rock type really? The metamorphic. Okay. Good job, Donna, you got it. Okay, and Martin. Martin's not here. Y'all couldn't get him up this morning?
He's babysitter. He's blaming it on the babysitter, which I think
I
is
bet you
smart.
told him he wasn't having a 3-course meal this morning.
Yeah, no meat. He's not coming.
Agatha.
They have layering.
They have layers, okay? And let me shuffle my name tags over here. Tim, give me another characteristic.
Positive acid test.
Positive acid test for only one, which is
Limestone.
limestone. Okay, good. And next is Brenna. Tell me one.
I put pressure and time, but I feel like we covered that, so I'm not covered it.
Okay, somebody, can you think of something else? Do you have anything else on your list? No? Okay, let me go to somebody else. Brenda.
So it also has organic material as well as inorganic material, so pieces of rock and pieces of like shell or.
Good. In other words, likely to contain fossils, plants and animals. Good. Okay, Shayna?
My group, not me, but my brilliant group said it's fine or coarse grained.
Fine or coarse grain. Sediments of all different sizes, from the very finest to gravel. Okay, all kinds of sediments, and there's a range of them. Your brilliant group did good. Teresa, give me another one.
Let's see. We said the layers are order oldest at the bottom to youngest at the top.
Whoa!
That was
That's our
good.
today's practice lesson. Good for you. The layers are ordered. You can relatively sequence, because the bottom layer is first, oldest, all the way to the top would be the youngest of the deposits. Okay, give me another one. Greg.
Our not so brilliant group is out of answer.
No, we're not. We said,
Anything else?
We talked about how they're soft, and I know that's not the right term, but they're crumble. Yeah, they break apart.
They're
easier and-
loosely consolidated
Yeah.
compared to the other two types,
Right.
certainly.
Because we talked about how they,
We just weren't sure what the right word was.
Yeah.
That's good. Compacted because of a load on top, but
Right.
they're just squished together.
because they weather so much.
Okay.
When you think about the two.
I have a question. So Donna teaches 5th grade, and she used the term crumbly versus loosely compacted. So 5th graders are not going to understand loosely compacted. Can she begin with the term crumbly and then build
Absolutely.
that into it? So
It's the
crumbly-
concept that you
Crumbly would
want.
not be sloppy language, it wouldn't mislead them?
It wouldn't mislead them.
Okay. I have to ask nice questions.
No, but I'm glad you brought that up, Dr. West, because it is, as I'm teaching my 5th graders, my goal is not to teach those misconceptions. And so knowing that, because they are gonna say crumbly, when I'm in math class and they're describing the attributes of shapes, and they're giving me some of these terms in that sloppy language, we have to pull it into 5th grade. That was what you said in kinder, first, and second. We're 5th graders now.
Well,
So-
I don't think it's sloppy language on the child's part.
Right.
I think it is social language level, or I don't know what the correct term is, but something like that. Whereas our job is to move them into building the academic language, but not necessarily test on every academic language.
I do know when I was going
Vocabulary.
through and explaining the sedentary rocks with my kindergartners, we use both. I would use the words that they understood, but I would also, and when you get older in the next year, this is the word that you're going to be using, so that way they can already be familiar with hearing it versus never heard it before.
Right. Sometimes it's a goal to move to that higher level.
And I think we do talk about, because I remember in my class this year talking about loosely compacted, because we really drive home the point of the layering of the sediment and, being able to age it by, the oldest to the youngest. And we actually layer some stuff, so.
Okay, Tanya, do you have anything else?
You already picked on me.
I'm picking on, I started over. You're not picked on. I'm putting Martin back in here now.
My turn.
You missed the breakfast. Oh, he didn't?
No, I think he took care of it himself.
We didn't have anything else.
Nothing else. Does anybody have anything else? We gotta move this along. Hurry. What? Anybody else have anything different? Where do you find them in Texas?
Along 281.
On 281, she says. I don't have my geology map down here, but you saw my geology map, and we made reference to it constantly. Most of Texas is covered by
A light
igneous, sedimentary, or metamorphic? Sedimentary. And overwhelmingly, most of that sedimentary rock is limestone, which results in, if you have limestone rocks, what kind of topography would you have?
a shallow thing.
Karst topography. So put that in your list. Karst topography. Limestone, most of prevalent at the surface in Texas, all of central Texas, all that green on that map is all limestone rocks.
How do you spell that word?
K-A-R-S-T. Karst topography. Okay, and there are two kinds of sedimentary rocks. On your key, there was a side over here and a side over here. And these on this side were made of stuff like sand and gravel and clay and particles. Yes. They were called clastic or detrital. And then over here were called the... No, conglomerate is made of gravel. That's one of the clastics. Over on the right-hand side of the chart, the sedimentary chart, those were things like rock salt and gypsum. Actually mineral deposits because the water can evaporate. So they're called the chemicals, okay? The chemical sedimentary rocks. So you went to Natural Bridge, right? And did you see the stalactites hanging tight from the ceiling and the stalagmites maybe growing to the ceiling someday? And those are chemically evaporated deposits of calcite. Okay? And so, so if you were going on a rock hunt, you would find an abundance of them in Texas, right? Which equates to one of the characteristics of karst topography is fossils, layers that respond to acid. So you're going to see holes and caves and caverns in them. And you're going to see that stair stepping. Those are the characteristics that you witnessed on the field trip, right?
And a vug.
And a what?
A vug. Anything that's 3 inches or less is a vug. Anything bigger than that's a cave. Is that right?
Yeah, that's right. Was it 8? I forgot all of that part right there. You learned something this game. Okay, we're going to hurry this. Okay, metamorphic. Get your list.
Oh, metamorphic.
Metamorphic.
Heat. No, this was the heating
You love that word.
I do. I learned that word. That's my word.
But
No. Is it straight? Yes, layers on the straight.
Striation does say that, but that old days does say that.
Look at Mark's.
Oh, I know that has something. Same here. I've seen
Okay, time's up. Here we go. Get your list going. I'm over time. Here we go. You're just so good. I like it. All right, ready? Martin, give me one characteristic of a metamorphic rock.
Chemical change.
Chemical change?
Physical change.
Some kind of change.
They are known as the hinged over rocks. That's true.
They were changed.
A changed over rock. That equates to the fact that every metamorphic rock has a parent. It used to be something different and it got changed. Okay, so I'm guessing that's where that word came from. Because chemical change, all rocks can go through a chemical change if environmental conditions are such. All right, Elizabeth, give us one.
Oh, okay. Heat and pressure.
What?
Heat and pressures.
And there's one more. Agents. These are called the agents. What has to happen to a rock for it to be metamorphosed? She said heat and pressure and
Space. No? Does it not matter?
there can be a chemical change. And most of the time it's water. Chemically active fluid is what your textbook calls it. Heat, pressure, and chemically active fluids. Those are the three agents of metamorphism. Okay?
Chemically changed is what it meant.
Oh, that's what he meant. Gotcha. Okay. Okay, and so did you put down that they used to be something different?
Yes.
Any rock can be metamorphosed, even a metamorphic rock, right? Okay, and so what's the number one characteristic? You got that down right?
Yes.
Or bands, you can call them either one. It's striated or it's banded. Okay, and where do you find them in Texas? And where? Central Texas Mineral. So that little purple circle on my Texas geology map, that's the igneous. But out around it is a ring. It's not continuous. It's more in some places than others. But those are the metamorphic rocks. When that stuff intruded, it was an intrusion of magma. And now it's been exposed. The stuff on top of it's weathered away. But out around it, when it intruded upward, still as magma, it changed some rocks around it. So you found some gneiss and you found some schist, and you found some marble.
Yes.
All those were metamorphic rocks out around the magma intrusion of the igneous, okay? All right, and aquifers or aquatards? Aquatards. All right, we're talking about a lot of pressure.
Yeah.
Some heat, not enough to melt it, but just to give it some fluid action so that like things came together, and that's what makes the bands, okay? All right, so you are ready, all right? And so you're going to be working on connecting all the arrows. We went through them, but you're going to do some labs, okay? All right, here you go. Sorry, I went over.
Okay, so you've got your handout on the rock cycle, and we talked about how that works, and we've reviewed everything that we looked at this summer. Today we're going to look at the hydrologic cycle, that's the water cycle, but not just, we know the water cycle, we're going to look at how it affects geology, how those two interact with each other. And then in the future, we're going to be looking at the tectonic cycle, so everything that happens below the earth and how it affects the landforms on the earth. So Patty's just taking care of your review. We've got our rock cycle going. Sorry, through our technical difficulties, we've swung and missed apparently a little bit. Okay, let me click. All right, water cycle. So we have above the land, we have the atmosphere. That's all the gases that are pulled down by gravity and are more concentrated on the surface of the earth than above. Then the lithosphere is the hard part of the earth. So the lithosphere is what we think of as the crust and the top part of the asthenosphere, you know, that plastic layer underneath. So we have the surface of the continents. The water there on the surface of the continents are the lakes and the streams. That we got that right, okay? Then we have the oceans. So the lakes and the streams flow into the oceans. So the water interactions there are transpiration, so the plants release water into the atmosphere, precipitation, and then we have evaporation. Then there's the water under the ground. It's our groundwater. So we have the water from the ocean transfers under the ground and seeps into the continental crust and into the earth. And then the groundwater is there because the water percolates down through the surface. And then a lot of times, especially around here, you see the springs, and we talked about that this summer, how the springs come up and the pressure forces the water up above. So are we all on the same page? This is just kind of a basic review for us. Okay, so we're going to look at how it affects the rock cycle. We've got our coastal plains. So this is big picture, guys. This is the continent, and then here's the sea, the ocean levels. So as water moves from up to down, gravity pulls the water down. It also pulls down sediments right here. So what this whole process is called weathering. First step is weathering, okay? That's the breaking down of the rock. There's two types of weathering, and we're going to go over this in more detail. This is just big picture. There's chemical weathering, where the minerals are actually chemically changed or dissolved, or it can be mechanical weathering, the physical crumbling up of the rocks. Once those pieces are made, then they have to be transported somewhere, and that's through erosion. Erosion is the carrying of those pieces to somewhere else. Water is the biggest agent that carries the sediments. Wind can carry it, so can ice. And then once energy settles down, that water slows down, all those pieces of rock that are being held in suspension, they start dropping out, and that's called deposition. Many times that deposition,
remember this?
Many times that deposition ultimately ends up in the ocean. Okay, weathering. Step one, chemical weathering. We're going to look at several different types. Now, who's the 7th grade teacher? 7th grade, anybody? Okay, you have a teak in 7th grade, and this is what you're going to be sharing. Carbonation. So we have our caves that are primarily made out of limestone or maybe dolomite. And so limestone is made up of a mineral called calcium carbonate, calcite. And we looked at that this summer. We did our acid test on the calcite. Y'all remember that when we were testing to see if the mineral was calcite? So whenever it rains, if the rain is slightly acidic, it percolates through the ground, it goes through the cracks in the limestone, and it starts slowly dissolving the calcite in the limestone, and it makes caves. Oxidation, you know what that is. We have our silver that gets tarnished, iron rust, copper gets that green stuff on it. That's another way that we can chemically weather something. And then plants actually can release an acid that dissolve rock. And, we'll go over that in a minute. But 7th grade, again, succession. When you're teaching succession, you teach that in primary succession, the pioneer species that whenever you have rock, the pioneer species that starts moving into that rocky area is called lichen. And what they do, their main job is to start breaking down that rock. So they sit on the rock, and one of their waste products is a weak acid, and it starts breaking down the rock, and that's the first step in soil production that leads to other species coming in and being able to live there too. The other type of weathering is mechanical. Sometimes you'll hear it called physical weathering. And it's just what it sounds like. It is the physical breaking down of rocks into smaller pieces. So abrasion is one. It's like sandpaper. When things rub together, they grind together. It makes smaller pieces. Roots can pry into cracks in the rock and make bigger cracks, and things fall apart that way. Remember, this is all a really slow process. We're talking geologic time. That's not like next week it will happen. Ice wedging is one that we look for too, and that's when you have a crack in a rock, water flows into the crack, and then when water freezes, it expands a little bit. And so it pries apart the rock a little bit, and then it melts. And then water comes in again, and it freezes, and it expands it some more, and eventually it cracks the rock away. Another one is exfoliation. So sometimes in rocks, whenever they're exposed to, intense heat, they'll exfoliate, and that,
Change from day to day.
so it will cause them to like peel off a little bit.
Like the, Jan rock.
Exactly, that's exactly right. Okay, yep, so we're really blowing through this. So we've got weathering. So weathering is the breaking down. Now we've got our pieces and we need to move them somewhere. That's called erosion. Erosion happens, we looked at water, wind, and ice. The biggest one is water. But water well, gravity impacts it. So things go from high to low. Gravity pulls it down. That's why you go from the mountains, you track it down to the oceans. Wind is important, not as much here, but wind is huge in the deserts where there's not much water. Ice and glaciers, they pick up rocks, they transport rocks, and they break them. They break stuff off. And then water's the most important. Okay, rainwater. The more rain, the higher the energy, the bigger the pieces it can pick up. The lower the levels of energy, the smaller the pieces it will carry. So you have your rainwater, your streams, rivers, oceans, like beaches. Beaches with sand, you see those shapes changing all the time, especially during big storms. So areas that weren't a beach before are now suddenly a beach, and your house is no longer there. Or there was an area that wasn't beach, and now there's, the beach has moved farther. So those coastlines change because of erosion. So any place that water moves, you're going to see erosion. Water's an important part of this because water it's a big, it causes a lot of weathering. So I had a picture that I can't show you because we don't have an overhead thing. That's a drop of water on a rock. You think, okay, that's not a big deal. But drops of water over millions of years will help you end up with the Grand Canyon. So you start out with a teeny tiny little drop of water, and then that over time, that little bitty thing ends up making huge, huge differences. Okay, like a splash. Tiny crater in the soil. It doesn't make a crater in the rock. If you have soil, it makes a crater. But then you have a lot of raindrops and huge amounts of rain, and you can end up with sheet erosion is what that's called. So whenever it rains, we want it to rain slow and steady so it has time to soak into the ground. But if it rains too fast, there's not time for it to soak in, and so it's going to go somewhere. So it results in huge flows of water, and and the soil will wash away if it's not held down by vegetation.
That picture reminds me of the gorge.
Yeah, that's what I was just thinking too. I was like, that's gorge.
Okay, whoop, wrong way, sorry. Okay, rills are like little bitty, well, there they are. They're small ditches, like early riverbeds.
And you saw those at the dinosaur tracks hurriedly, remember the storm runs out? But out in the middle of the river, you were seeing rills.
Yes.
Some people have said to me, are those the dinosaurs dragging their tails?
Okay, when rills, you see how there's one big rill, but there's others forming around it? When those rills get bigger and bigger, then they combine and they can make a gully. Those gullies are, yeah, gully washers, there it is, right there. So once that happens, you're kind of, you know, there's not a lot you can do to stop that. Rills, you can stop that with more vegetation on the soil. Ma'am?
Small ditches.
Small ditch with water in it?
Right?
And difficult to stop, like to stop them from forming?
To stop them from progressing. Yeah.
As a matter of fact, if you'll start watching, out around Ulen, there are some gullies like this that the highway department is working desperately to slow down the headward erosion of that gully because it's fixing to come across 21. And then we're in the bridge business, okay? And so in areas like that is a very poor land area because it was cotton way back during the Depression years, and it was overplanted year after year after year, and so just Roosevelt Willow has come in and it's very, very poor soil. No, not much good soil at all. But you'll see gullies all over that area. And if you out here below the escarpment, towards that way, with some relief, you will see features like this.
Well, and, you know, Texas has had a really bad drought over, I mean, it's been probably 10 years in some parts of Texas. And I grew up about 5 hours north of here. This is a huge problem for us now because there's hardly any vegetation. Grass, it's like, if you see something green, we're like, oh my goodness, what's that green stuff? But now we have a huge issue with erosion because there's no vegetation holding the soil in place. So when it does rain, everything just, it does this, which is no good. Okay, so here is a picture of in Iowa that has a lot of those features in it. There's heavy rain that resulted in this. So it started with a sheet surface water runoff. The rills began and then gullies are setting in. Okay, deposition, you ready? Deposition, so once things weather, then they're moved, eventually they're going to be put down somewhere or deposited. So deposition, when you look at your sedimentary rock, you can figure out how much energy was in the water whenever these sediments were deposited. If you have huge clasts, like this big, you know there was a huge storm that moved that big boulder. But if you have teeny tiny clay, like in the shale or you know, little bitty sediments that you can't even see with your naked eye, you know that those were the little bitty pieces that resulted from still waters. So in Patty's sediment tube, whenever you shake up the sediment tube, do y'all remember seeing this last summer? The larger pieces are at the bottom, and then even though this water is still, there's still some like mud sediment up in here that will take a long time to filter out. So that will result in clays and such. So here's another one. Y'all remember this? We made one last summer. So we see features because of deposition, like alluvial fans. So whenever water comes off a mountain, it's going real fast, and then once it hits those flat lands, it spreads out and the water velocity decreases, energy decreases, and so the deposits look like a big fan coming out from the mountains. We end up with river deltas, like the Mississippi Delta. The Mississippi River has huge amounts of energy. It's huge. It's carrying all of these sediments. And then once it hits the ocean, it has room to spread out. And so the energy decreases. And so you end up with a delta. A delta just means triangle. It's like a fan out in the ocean. Rivers. Rivers, they carry water, but they can also deposit sediments. So they are agents of erosion, and there's deposition that goes on too. So think about a river as it flows around. What that water is moving faster on the outside curve than it is on the inside curve. So on the outside curve, there's more energy, and so it's eroding the sediments on the outside. But on the inside is when the energy slows down. So what's going to happen on that inside curve?
You get stuck in your tube.
You get stuck in your tube. You have been deposited in the river. So meandering, that just means wandering. So think about a river over time. Whenever the outside curve gets eroded and the inside curve gets deposited upon, you see those little beaches. What's going to happen to that river over time?
It's gonna change.
It's going to keep moving and moving. So it's a river that is slightly curved is going to become more and more meandering. And eventually, it's going to,
Sorry.
oh my goodness, bucket of water.
It turned on.
So eventually that river, those pieces that erode out, it gets so meandering that a storm comes along and it's going to cut through and cut off those curvy parts on the edge, and you're going to end up with the oxbow lakes. So whenever you're in an airplane and you're looking down on the land and you see a river, but then they have these little horseshoe lakes on the sides of it, you know it's a really old river. Sand dunes. We don't really have a lot of sand dunes here in Texas, but New Mexico deals with them, southern New Mexico, those desert kind of stuff. So as the sand dunes move and then eventually they are lithified and cemented, then you can see those structures and sedimentary rocks are pretty cool. And then our beaches. Beaches are when sand is deposited onto the shore. And then last, we have the sediments on the floors of lakes and oceans. And that's last because that's where the energy is lowest. So are those sediments going to be really large or really small? Small. So we have a lab that we're going to do.
They've been in here an hour. Can they take a break?
That would be a great time to take a
We
break.
call it a mind break, so what I require my students to do is you have to get up, you may not stay sitting, and you have to walk.
Oh, okay, so